Good morning. We will talk about how the function fork in the Linux operating system. All right. So let's pretend we have a variable PID equal to fork. Okay. So before we get into this fork business, we need to review the memory address space of any process. Okay, so we know there are a lot of segments in your executable a dot out. That could be the kernel code, that could be the environment variables, this could be the stack area, this is the heap area, right? There are variables which are initialized, variables that are not initialized, and then your actual code. Your actual code and that instruction set is a dot out. Here, like I said, variables that are initialized or not initialized, variables that are not initialized, heap. We talked about the heap that goes with the stack, and there are a bunch of other segments called we also have, this is the say kernel code, right? And the environment variables, uh, arguments that you pass. So like I said in the class, you have to get the layout of this executable in your head for the rest of your life. Okay, this is not going to change in near future, probably for generations, so it's better to get used to this. And the so when so your program is running and you are executing a function called somewhere here. Okay, somewhere here, let's say you calling a function called fork, and when you call the fork, that is the call to the kernel to create a child process. So as soon as you say that I want a child process to be created, it goes to the extensive instruction set to create a clone of your child, of your parent. So this code, this is the parent, and this is the child. We talked about that. And this is the identical instruction set as your parent. All right. Now, what is the use of two programs running in memory when they are the identical code, right? You don't need to have identical code running in your system. There's no point in that. So what happens is, let's zoom in this part. Okay, let's zoom in this here. Okay, this part of the code. Okay, let's zoom in here. Pretend we are zooming in, and you have PID equal to fork. And what happens is, so here also let's zoom in. See here, zoom in, PID, so equal to fork. So when you call the two identical programs, two process ID, let's pretend the ID of this process parent is 200, ID of this child process is 205, for example. There are two running two systems, two process running in the system, running identical, everything identical. Okay, if you have a variable that you are declared 10, here also x equal to 10. All right, at any time you have variable that you change to 30, for example, right, that will be 32. So it's identical bit by bit. So that's why fork is an expensive operation. Expensive operation. It's not easy because you got to open, clone the file descriptors, clone the page tables, all memory, stack, heap, everything has to be cloned. So this is a time-consuming process. Okay, So now what happens, the kernel is executing this code, is trying to do the job for you. And what happens is, the operating system says, let's PID is a variable, right? So memory locations, let's say memory location somewhere PID here, PID. So that as a value, the operating system says your value is 205. 205 is the child process ID. So that operating system does it for you like a magic wand. You don't have to do anything for that. Whereas here, which is the same PID variable that I was talking about, here the operating system says you get 0. That's it. That's the standard. That is the way it is done to distinguish between these two processes. This is the one at this moment, okay? At this moment when you execute fork, the only difference between two programs, these two processes, the PID value. This guy has the child, like an umbilical cord is having a tight uh, pointer to that. That's all it is, okay? It holds that child process, and the process of the child, he doesn't care, and so he gets the value of 0. So now two processes are running in the system. So we'll go here, right? So how do I now force my child to execute a simple code? Okay, the idea for a fork is basically the child process has to execute some code for me. That's all it is. Why? What kind of code you were talking about? The code can be somebody has requested a page from your website, right? Said www.google.com, for example. And when you say this on the browser, this request goes to the child, to the server, right? And the server says, I'm going to create a child for you, and he will serve this page. The child will serve this page to the user. That's all it is. There are millions and millions of users calling Google on a given day. You have millions and millions of child process serving you that web page, whereas the parent, he keeps forking and forking and forking. That's all he does. And the child serves the page and it gets terminated. So this is a constant code that runs in the server. It's a constantly forking, serve the page, the child gets terminated, then so it is a non-ending operation. Okay, so enough of that. Okay, so now if you go back here, and so how do I make force my child to execute some code? I'll say if PID equal to 0, right? I will print um, print the child process ID, right? Child process ID. Else, this code that you see here, okay? Remember again, is the code that is executed by the child. All right. And generally the idea is once the child has done executing its code, whatever it's supposed to do, it has to terminate, right? So we generally call exit function right there. Okay, that exit function will terminate the child. So the child will not execute any code here. It won't even spill over here to execute the parent code. So as that will be the last code that the child executes, that means terminate. All right, so that is the code. So now in the parent, I wait. We'll talk about wait later. And so this is what happens. So here the parent will be executing on its own, pretending as if nothing has happened, where the child gets created and it does the job and exit. Okay, so this layout of memory is something you have to remember for the rest of your life, how this thing is done. Okay, so again, this PID equal to 0 is a value that's set in the client code, so the client can check, hey, what is my value, right? Can check the value, and if the value is 0, then the child says, I can execute my code, right? And if it's not, the parent will wait and do, or you can doesn't have some places it won't wait, it go back and execute another fork. So this can be a while loop altogether, a while loop, or constantly running throughout the lifespan of the server. All right, as so whenever the client issues a request, a fork is done, a child is created, and the process goes on. Okay, that is how um, uh, that you force your child to execute a code. Thank you.